Uh, it's April 15th. It's 4 a.m. And this is supermushmouse. And this is a star on the right-hand side of Orion. This is the north side of Orion tonight because it's facing west. So this is the farthest outside star in the middle of Orion and also on the north side. And what I'm doing tonight is making a comparison between this and another star I took a video of a few days ago, which was not in Orion, but to the left of Orion, and it was pretty far out, considering I used a lot of zoom to get to it. It wasn't a visible star by naked eye. This one is visible. So you make a quick comparison just to see how they differ, or if they do differ. So this is in Orion, and it's the star on the north side tonight of Orion. Okay, April 15th, 4 a.m. and this is supermushmouse. Okay, all those little orbs there in the frame, they're not so small. Some are larger than our planet. Okay, but you can see how fast they're moving. Okay, and they're all following counterclockwise motion in many different directions in what I call the parent cluster for that star, because the star is the nucleus of that cluster. Now the whole constellation of Orion may be in the same cluster, but each star will have its own designated star cluster base that just feeds the orbs to that star, or that cluster regenerates those orbs out of the cluster by providing energy for them and recharge. But it's like a patchwork, that the entire constellation may be just part of one cluster, and each one having its own designated mini cluster within the larger one. So okay, you can see that it's a large star already. Okay, the closer I get to it, the more it's gonna move. But I fixed my stand better, because the other night I was having a whole lot of trouble, but that's because it was so cold, and I don't know exactly why it was so cold, because the temperature wasn't as cold like when I looked at the TV. I was looking at the temperature at the weather channel, and the temperature wasn't that cold. It was minus a couple of degrees, but all my bolts and everything was getting loose on the stand. And that's happened before to me, but only a few times when there was like a large orb cluster close to me. And the one time I really remember that happening, when the temperature dropped a whole lot, was when I made that second video of photos and video that's part of the Beings of Light video. It's like camera 2, I think, or camera 1. I can't remember which camera I numbered it, but I took a, that night, 2 different 2 different I mean, I was using two different cameras to make the same video with both cameras part of the video, or the images from both cameras part of the same video. And the thing is, when that wheel, within the wheel, which was a large circular formation of orbs, and that showed up and just kind of slowly moved over my head after it had been zooming around like a ball of light all over the place, and it was too fast for the camera. When I finally got one good shot of it, then the temperature really went down because it was close to me at that point. And I almost dropped the camera off the 18th floor because I was at my mom's place and she was on the 18th floor. So I almost dropped the camera down on top of that, pavement on the bottom from the 18th floor. I was barely able to hold the camera, how cold it got. It seemed like the temperature dropped like 100 degrees in a matter of seconds when that thing went over me. But that's the only time I remember seeing like a UFO right over my head, and the temperature dropping so low. But at other times, there's been a lot of smaller orbs in that particular wheel of orbs. They can also drop the temperature because they come in from space and they just drop the temperature really, really low. So what I'm doing right now is like I have to hold the camera on the star, because if I don't, what happens is that it just goes right off the screen, because I'm so close to it now that it moves too fast off the screen. I can't just let it go. So there's going to be some shaking, but not as much as the other night. Because the other night the whole stand was just being loosened up, and I was having a whole lot of trouble with the camera, or the stand staying in one place. So you can see that there's a lot of orbs in that cluster that's designated to the star itself. And what that cluster there is doing, the nucleus, which is the star itself, is it's recycling all those orbs by charging them up. And that's its purpose, to recharge the orbs that make up that not just designated cluster for the star itself, but the larger parent cluster, which may include all the other stars in Orion, because that whole larger cluster could have more than one nucleus, and all the stars in Orion can be just nuclei or a huge cluster, and I'm talking about an orb cluster. Okay, and all those things there are orbs, and each one of them is many times larger than the Earth, because this is a star which is very far away, and these are very intelligent entities, and they're energy entities that can manifest in material forms. And each one of those orbs can splinter into like smaller units, because it's made up of orbs, and it can just keep splitting and splitting into smaller and smaller units, which are also clusters themselves. So it's like a whole bunch of clusters within clusters within clusters, and just as the nucleus is a cluster of a whole lot of orbs that you see right there all around it, and then the larger cluster is just another cluster which includes the nucleus and all those orbs, and then includes perhaps all the different stars in Orion, in even a larger cluster, because it's the patchwork of clusters which are bonded together in space, and that's our universe. That's how it works. It's just a patchwork of clusters which create these nuclei, and these nuclei are energy points that allow these organisms to live. And they're intelligent. I can't even begin to say how intelligent, because they're really they're highly intelligent. I've seen some really strange and wild things that they can do, and they can also be very, what would I say, they could be not very nice sometimes, because they don't like anyone spying on them. Not that I consider this spying, this is more of an interest. I don't consider it spying. I just want to know what's going on. But sometimes they don't feel that way, and when they really get upset with me, taping them or filming them or taking pictures of them even, and they'll send a pulse, and it comes in form of a flash, and it's very fast. By the time you realize what's happening, your camera is burnt up, or everything inside is either melted, or I had one explode on me. Some just got damaged beyond repair. I had to throw them out. So I had 3 cameras actually totally destroyed, and some damaged. So I always keep spares because of that. It could be expensive, especially if you're getting cameras that can, go this far out and have the clarity and the lenses that the cameras have. So you can see that the orbs are spinning counterclockwise, and every now and then you see some trying to escape the nucleus and get pulled back in, and that's the electromagnetic field created by all that counterclockwise velocity in the revolutions around the center of that nucleus. And it's like an electromagnetic field right at the center, and there's another one at the edges. So what the orbs that are in the nucleus have to do is reach escape velocity to get out of that nucleus once they go in. But the outer membrane, which is around the nucleus itself, on the outside, where you see all that red, that's radiation. But between the yellow or white and the red, there's a magnetic field, and that field acts like a membrane, and it's very selective. It only allows orbs that are totally expired in energy to go into the nucleus, because if it let all of them in that want to come into the nucleus and recharge, the nucleus would immediately dissipate, because there would be too many orbs grabbing too much energy. So only the ones that really need it, to survive before they expire, they're the ones that can go in. But then they have to stay in until they're fully charged, because until they're fully charged, they can't reach escape velocity, and unless they have escape velocity, they can't get shot out of the nucleus. So it's a constant like exchange, and that nucleus just keeps going like a lawnmower through that large cluster, and takes in orbs and spits them out. It takes them in when they're really low on energy and spits them out when they're charged. The other thing that nucleus does, it's a stargate, and orbs from other stars, like that could be like at the other end of the universe or even somewhere else, and other dimensions as well. They can travel through these gates and come out almost instantaneously. And all of these stars, they're different nuclei, they're stargates, so they can wind up from one end of the universe to the other in, I don't know in how long, but it's almost instantaneous. So I don't know how long that would be. It's almost instantaneous. There's not telling how long that is, because I don't think we have any clocks that could really time that kind of transfer of energy. It just happens so fast that since, to us it's immediate, and that's it. So I'm going to back off because it's hard to keep holding it all the time. I just want to show the size of that cluster. Okay, I can go back more. Okay. Okay, it's huge. And you can really see the speed that the orbs are moving at tonight. It's not always the same speed, and it's not always the same speed even tonight with each star. Like I'll shoot another star in a minute, and I won't stop the camera. I'll just try and find another star after this one, just to show you that it may not be the same on another star. Maybe in this cluster is the same, and that's the only one I can see right now because it's right in front of me. And the speed may be the same, but it might not. I don't know, because sometimes it is, sometimes it's not, and I have to actually go and check it out. There's no way to tell what the speed is until you check it out. So you can see the counterclockwise movement, okay, and you can see the orbs being shot out of the star. And you can actually see them going into the star. They're shooting in and they're shooting out, okay. So there's a lot more of them trying to get in, because all of them right there, all around it, they're trying to get in. They all want to get into the nucleus. But you can see that they're being shot out in 6 different points. And it's like if you put an X through that star, and then put another line across horizontally through the center, those are the 6 points. And that's because the star is a hexahedron, and that's its natural shape. So the orbs come out at 6 different points, and sometimes it's very obvious because it's more visible than tonight. But the orbs leave at 6 different points from the nucleus, from the star. Let's see if I can get that. Okay, I'm not at the right exact angle to show that tonight. I don't want to really move it right now, just for that reason. But that's the 6 points that orbs shoot out, and every star is the same. It shoots things out at 6 different points because it's a hexahedron. You can see right there in the center, if you draw a horizontal line through the center, you can see on the right and the left where they're shooting out. You can even see some, they're supercharged. They're really bright white. They shoot out. Now that I lost it. See, that's the trouble with being too close. You can lose it real quick. Okay, so this is a high radiation star. Okay, the more red you see around it, the higher the radiation. And you can see that the nucleus changes shape all the time. And the way the spin is around the nucleus counterclockwise, the momentum is so high in the spin that the mass of the nucleus, the energy itself, is like always trying to catch up to the velocity. So it looks like it's dragging itself around. If you look at it carefully, that's exactly what it's doing. So it's like lagging behind the velocity of the spin. So all these orbs, they have a positive and negative charge, and when they're in the nucleus, they exercise that charge by either connecting or disconnecting, and the spin of the orbs inside the nucleus, it creates an electromagnet. It acts like a dynamo, and that's how the energy is produced. I've shown a few videos where you can see like arcs shooting through the star from one end to the other. Well, that's the reason that happens, is that there's like a positive and a negative charge, and then the conflict between the two causes those arcs to shoot through the star. And the more that happens, the more energy there is in the nucleus. So that's a necessary thing to having a nucleus like this, is the conflict between the charges, the positive and the negative, so that the nucleus itself can stay in operation. Okay, I'm going to back up and see if I can get a different star. That one's bright, so it was easy to see. The rest, I don't know. Okay, I'm just going to drop down a little bit and try and get another one that's just below it or next to it. there's that one. Okay. Okay. Here's another one. Let me just set up. Okay. This one is not as visible. It's visible by the naked eye, but not as much. Okay. Okay, this one is not as hot because, let me just set this up. Wait, I lost it. Okay. I have to hold it. Okay, it's not easy to try and get it at like the zoom level. Okay, this one is not as hot. It's yellow, so it's not like white hot. This is a higher radiation start because you can see that there's more red. I have to try and get closer. Okay, you see the pulse on this star? It's very different than the other star. But the orb velocity around it, it's pretty close to the other one. But you see the pulsing of this one? It looks totally different than the other one. This is a higher radiation star. So the frequency here is different. Okay, that doesn't mean that tomorrow night or in 5 minutes the frequency can't change and this will be bright white and that red will, you know, not be as red, and it could be more blue and it could be more visible where that yellow center is. It would be brighter white and more visible and maybe even look larger. But right now it's got a slower vibrations frequency and a slower velocity in that nucleus. You could see that it's got also larger orbs inside the nucleus.